I want to show you a recipe that I see some version of it constantly. Olive oil, coconut oil, shea butter, and then some exotic, expensive, fancy sounding oil like avocado oil, rosehip oil, grapeseed oil, or even a combination of all of them. The logic behind it is that these oils are expensive. They contain some really good ingredients like vitamin A, vitamin E, some of them vitamin C, certain antioxidants, and these are oils you will find in high-end serums and face creams in the skincare industry. So then why not use them in soap? So the properties that make grapeseed oil a phenomenal oil in a face serum, like the polyphenols, the vitamins, the antioxidants. They are also the properties that are either destroyed by the soap making process or just washed down the drain because soap is a rinse-off product. So I'm not here to tell you that these oils are bad oils. They are not. They are excellent skincare oils. But what I'm gonna show you today is that soap is not the right environment for those oils to put them in, and where you should actually use them. Before we look at each oil, grapeseed oil, rosehip oil, argan oil, avocado oil, macadamia oil, and so on, I want us to actually look at the saponification reaction and look what soap does to an oil. So soap does not care about all the vitamins, all the antioxidants. The only thing saponification cares about is fatty acid profile. Just that. And if you're new here, my name is Perry. I am obsessed with understanding formulation and the chemistry behind things, and my aim is to inspire you to not only copy recipes, but to also design your own recipes based on your own goals and understand the why behind each ingredient, so that by doing so, you save a lot of money, time, and energy. I've helped hundreds of soap makers transform their soap and skincare making through my transformation system and through my ebook. And I would love to do the same for you. So when you mix an oil like coconut oil, shea butter, olive oil, castor oil, beef tallow with sodium hydroxide, otherwise known as lye, then basically sodium hydroxide reacts with the fatty acids that exist in these oils and butters to create soap. This is the typical saponification reaction between oils, sodium hydroxide, and the product is soap, and the byproduct is glycerin. And the way it happens is that oils contain triglycerides. Basically, triglyceride is the combination of 3 fatty acids with 1 glycerol molecule, and it looks like that. So we have glycerol and 3 fatty acids. And then we have sodium hydroxide. Sodium hydroxide is basically sodium atoms and hydroxyl atoms. And those hydroxyl atoms are highly reactive. They're the reason why sodium hydroxide solution is so alkaline and so caustic, and that's why you should be very careful when you're handling lye. So the hydroxyl group attacks the bond between the glycerol and the 3 fatty acids. Then the 3 fatty acids connect with sodium, they produce soap, so this is what soap is, and also the glycerol molecule is released. And that's how we get both soap and glycerol, and that's why soap making is so unique, because glycerol is a very moisturizing molecule, is a humectant, basically traps moisture into the skin. So we have both soap that cleanses and glycerin that protects. And what happens, what's very unique here, is that soap making happens in a very high pH and high temperature environment, because sodium hydroxide solution has a pH of 14, which is the highest pH a solution can have, which means it's super harsh for certain ingredients. So the only thing that matters in saponification is the fatty acid profile. Olive oil contains oleic acid. Oleic acid reacts with sodium hydroxide to produce sodium oleate. Coconut oil contains lauric acid and myristic acid. Those react with sodium hydroxide to produce sodium laurate and sodium myristate. Castor oil contains ricinoleic acid. These react with sodium hydroxide to produce sodium ricinoleate. Shea butter contains stearic acid. This reacts with sodium hydroxide to produce sodium stearate. Beef tallow contains both stearic acid and palmitic acid. Palmitic acid reacts with sodium hydroxide to produce sodium palmate. So the only thing that matters with lye and saponification is the fats. What fats does your oils contain. And as you can see, every fatty acid contributes to a different property. For example, lauric acid, when it reacts with lye, it produces sodium laurate, which is basically something that contributes to a lot of hardness and a very bubbly lather. So it creates a lot of bubbles, and it's the reason why we have a lot of fluffy bubbles. So coconut oil, babassu oil, palm kernel oil, they are all the reason why we have a lot of bubbles in soap. Oleic acid leads to conditioning, stearic acid leads to creaminess, palmitic acid leads to a more stable lather, linoleic acid leads to conditioning, but it's a more unstable acid because it also oxidizes very fast and leads to the so-called dreaded orange spots. So this is what soap cares about. What saponification does not care about at all is vitamins like vitamin E, vitamin C, carotenoids, polyphenols, phytosterols, and antioxidants, because those are very, very unstable ingredients and they get degraded in a harsh environment of a high pH and also high temperature, because saponification releases a lot of heat. And this is exactly why I tell people that you don't need 100 ingredients to make soap. You don't need to waste money on very fancy ingredients to make soap. You can literally make a lot of all of the soap products you can imagine with only 4 oils. And that's why I put together a free PDF that shows you how you can make 6 different skincare products with only 7 ingredients, from dish soap, normal soap, sensitive skin soap, shaving soap, deodorant, lip balm, and so on. If you want this free PDF, comment "I want the system" and I will send to you as soon as I see your comment. So let's look at the different oils now. Let's look, for example, at grapeseed oil. And here you have grapeseed oil. Basically, it's high in linoleic acid, which leads to conditioning lather, but at the same time, it leads to oxidation. So it goes rancid very, very fast. It leads to dreaded orange spots in soap. So it's not a very desirable oil just from the linoleic acid concentration. Apart from that, all these vitamins, polyphenols, flavonoids, they get degraded. And also, more importantly, it's very high cost. So you buy something very expensive that has a high chance of oxidizing and no chance of providing any of the vitamins it promised to in soap. This is just to show you that with these oils in soap making, mostly wasting your money. Then we have rosehip oil, that's even more expensive. Also high in linoleic acid, has some amazing ingredients like retinoic acid, vitamin C precursors, carotenoids, but they all get destroyed. The same with argan oil, quite expensive, and avocado oil. This is a bit better when it comes to linoleic acid, so it's lower in linoleic acid, so it's a safe oil to use in terms of rancidity and oxidation. It also gives a nice green tincture into soap, so it adds a bit of color to your soap. That's the only reason why I would recommend people using it perhaps in a maximum 5 to 10% concentration, but not more. But it's also slightly more expensive than traditional oils like olive oil. So what happens to all of this good stuff? So not only do you have a high pH, so in the start, during saponification, you have a pH of 12 to 14. The finished product has a pH of 9 to 10. At the same time, you have a lot of heat released and a lot of these great compounds get degraded, or if it's a protein, it gets completely denatured in a high heat environment. And then they're also exposed to oxygen during the curing time, which is typically 4 to 6 weeks, and exposure to oxygen leads to more degradation. Apart from that, soap making is a rinse-off product, so you literally put it on your skin for a few seconds and then you rinse it off. So a lot of these great vitamins, even if they survive saponification, they don't have time to penetrate the skin because you rinse it off so fast. While with leave-on products like hand creams, lip balms, face creams, and so on, all of these bioactive molecules, they are intact. And this is where I recommend people using grapeseed oil. If you're making a lip balm, it's great to use grapeseed oil or avocado oil or rosehip oil. You really get the benefits of those oils on your lips. The same with face creams or hand creams. It's quite good to use some of these oils there as well. And those are leave-on products. You leave them on your skin, so all of these nutrients, they have time to penetrate and actually do their work. And don't forget to comment, I want the system, to get the PDF that shows you how you can save money when it comes to soap making and not buy hundreds of different ingredients, but do everything you need with very few ingredients, create many different skincare products, and only use the oils that actually work. Write down in the comments below if you have actually used those oils and if you have gone through this yourself, because I know I have used grapeseed oil, I have used avocado oil, I have used all of these oils, and when I was starting out, I was spending a lot of money without knowing what I was doing, and I don't want the same for you. So comment down below if you have gone through this yourself, and I really hope you enjoyed this video. I'll see you guys next time.